To understand quicksort, you must need to know recursion. First of all, whenever you hear the word quicksort, I need you to remember pivot. Pivot is a point in an array around which the array is sorted into smaller on the left and larger on the right elements. There are different versions of quicksort. Depends on how you pick the pivot. We can pick the pivot, the first element, the last element, the median as a pivot, or a random element, which is also known as randomized quicksort. Randomized quicksort, mostly it performs the tasks in time complexity of n log n. This is because in randomized quicksort, an element is picked randomly, and mostly the randomly picked element is not the minimum or the maximum of the array. Quicksort has two functions, partition function and a sort function. In quicksort algo, we have two functions, the partition function and the sorting function itself. I will show you the quicksort in which the leftmost element is the pivot. So what the partition method does is take the leftmost element of the array and traverse it through the whole array and fits it into the position where it belongs. It takes all the elements that are smaller than the pivot on the left side and all the elements that are greater than the pivot on the right side. In our case, 56 is our pivot. We come to the partition method and see that there are two variables, I and j. I tracks the position of where we are in an array, and j helps us to traverse the whole array. Okay, if you look into the algorithm of the quicksort function, what we see is there's a base case in which low must be less than high. Following statements are executed. First of all, we find pi, which is partition index, which is the result of the partition. What partition function does, pick a pivot point and arrange the elements of the array such that the elements that are less than the pivot are arranged on the left side of the pivot, and the elements that are a pivot are arranged on the right hand side of the pivot, and it returns the pivot index, which we save in the pi variable. As the next statement executes, what it does is sorts the partitioned array. When we call the quicksort function for the first time, it sorts the array that are less than the pivot. So what parameters we pass is the array itself and the lowest point, which is index 0 for sure, and the highest point, the highest element, the highest index is pi minus 1, which is the pivot point minus 1, because the pivot is sorted already, so we don't have to traverse through the pivot. We just have to traverse from the lowest point to the pivot minus 1 the second time. What it does is perform the quicksort function such that the lowest point is pivot plus 1 and the highest point is the highest point of the array itself. Let's see how pivot performs this action. As you can see in the algorithm, partition function accepts three parameters, the array, the lowest point, and the highest point. Now, it creates a variable I. What I does is track the position at the moment. So, first of all, so to start, we have to be 1 minus than the lowest index. As we proceed, we select the highest element of the array as pivot, as it is the leftmost element of the array. So what for loop does is create a new variable which helps us traverse through the array. So what we see here is if there is an element that is less than pivot, then we increment variable I by 1. Now I and j are at the same place. Now as 42 is less than 56, I increments and it becomes 0. Now j is 0 and I is 0. These elements swap, and when they swap, they don't change position. Now the loop executes and j is incremented by 1. It reaches index 1, at which the element is 30. Now 30 is less than 56, so the same approach applies. What it does is increment I. and swap it with j, which remains the same. For the next element, 64, the 64 element, now the 64 is greater than 56, so the condition of for loop, that is inside for loop, is not satisfied, and therefore as j is incremented, I is not. Now I is index 1 and j is index 2, and if condition is false. Now j is incremented again as loop carries on. J is now 3 and I is 1. Now the element at index 3 is less than the pivot, that is 56. Now what it does is increment I again. Now the I is 2 and j is 3, and what it does is swaps the both values 21 and 64. Now the array becomes 42, 30, 21, 64, 77, 96, and 56. Now j is incremented again, and as it becomes 4, the I remains 2. As 77 is greater than 56, the if condition becomes false. J is incremented again, as 96 is also greater than 56. If statement does not execute. Now the for loop is ended. As the for loop ends, the next statement shows that I plus 1 should be swapped with the pivot. And now what was I? Now I was 2 and I plus 1 should be 64. And 64 is swapped with 56, that is the pivot. Now here it is swapped, and this, after swapping, we see that 56 is at its right position where it deserves to be. The partition function returns this position, and this position is then stored in the pi variable in the quicksort function. As we see that partition function performs all the actions, that is, it traverses all the elements of the array. Therefore, we can say that time complexity of the partition function is n. Now, if we come towards the sorting function, what sorting does is use the approach of divide and conquer. Now, what it does is divide the array from the pivot point into smaller ones and larger ones. The smaller ones are then again divided and then conquered, and same goes with larger ones. Now as it divides the array into smaller and larger elements, it performs the function every time with n by 2 complexity. The worst case applies when array is sorted in the opposite order and we select the first or the last element that helps in sorting the array on the other end. That is, we have to sort the whole array and then fit the pivot at its lowest or largest point where it should be. As it has to traverse the whole array, again, the worst case time complexity of quicksort is n square. The best case applies when the array is already sorted. As the pivot finds its way through the array, it finds that the array is already sorted and it is where it should be. So the best case complexity remains n log n. In the average case, the pivot is selected a random element, and the random element can be any element other than the last and the first element, and it may fit anywhere in the array. So mostly this randomized quicksort gives us the average time complexity n log n.